Atomic physics is the study of atoms, their electrons, energy levels, and interactions with electromagnetic radiation. An atom has a nucleus containing protons and neutrons, surrounded by negatively charged electrons. Electrons cannot have any energy they want. They occupy specific, quantized energy levels. When an electron absorbs the correct amount of energy, it moves to a higher level. During absorption, the electron gains energy from a photon. The energy of that photon must match the difference between the two energy levels. When an electron falls from a higher energy level to a lower level, the energy difference is released as a photon. The energy of a photon is given by E equals hf, where h is Planck's constant and f is the frequency of the radiation. For example, an electron requires 4 times 10 to the minus 19th joules to move to a higher energy level. For an emission, the photon energy equals the difference between the higher and lower energy levels. Using F equals E divided by H, the required frequency is approximately 6.03 times 10 to the 14th Hertz. For 3 times 10 to minus 19th joules, the photon frequency is approximately 4.52 times 10 to the 14th Hertz. Because electrons can only make certain transitions, atoms produce specific frequencies of radiation, called line spectra. Each element produces its own unique pattern of spectral lines, allowing scientists to identify elements from their spectra. The speed, frequency, and wavelength of electromagnetic radiation are related by C equals F lambda. Combining E equals HF with C equals F lambda gives another useful equation, E equals HC over lambda. For example, consider a photon with a wavelength of 600 nanometers. First, convert the wavelength into meters. Using E equals hc over lambda, the photon energy is approximately 3.3232 times 10 to the minus 19th joules. The lowest possible energy level of an atom is called the ground state. When an electron absorbs energy and moves to a higher level, the atom is said to be in an excited state. Ionization occurs when an electron gains enough energy to escape completely from the atom, leaving behind a positive ion. The minimum energy needed to remove an electron completely from an atom is called the ionization energy.
Suppose an atom has an ionization energy of 2.18 times 10 to the minus 18th joules. We can find the minimum photon frequency using E equals hf.
Dividing the ionization energy by Planck's constant gives a minimum frequency of approximately 3.29 times 10 to the 15th Hertz. Consider an electron falling between two energy levels separated by 5 times 10 to the minus 19th joules. Calculate the wavelength of the emitted photon. Rearranging the equation gives lambda equals hc divided by E. Substituting the values gives 3.98 times 10 to the minus 7th meters. This is 398 nanometers, which lies in the ultraviolet region of the electromagnetic spectrum. The key equations to remember are E equals hf, C equals F lambda, E equals hc over lambda, equals the difference between the energy levels. Remember the central idea. Atoms have quantized energy levels. Electrons absorb energy when moving up and emit photons when moving down. The energy of the photon involved is equal to the energy difference between the two allowed levels.
Master these concepts, and you have the foundation needed to tackle A-level atomic physics problems with confidence.
If you enjoyed this lesson, like, comment, and share it with others. Subscribe to UNIC EDU for more high-quality educational lessons.